Now these video tutorials, of course they're going to help you come up with answers so you can finish your homework quickly. But they're also an opportunity for me to go into detail and describe problems that would take too long in lecture. So I want you to, yes, surf these videos and get answers from them quickly so that you can finish your homework quickly, but I don't want you to not think about them in general terms as well and take not just the answer for your problem, but learn lessons of general approach so that that these videos can help you in the future for writing tests and also give you insight into physics generally. Anyway, keep your wits about you when you're watching these videos and try and take some fundamental tips from them if you can, based on what I'm doing, and apply it to all situations that are similar to what we're doing in the problem, and not just an answer to a specific question on a specific homework. The question involved here is about an object on a slope. I want to, which are very important in physics. So let's assume the object is a piano, which I'm going to, in the boring way of physicists, just approximate a piano by just some cube. Now here's a piano sitting on a horizontal surface. It has all objects with mass have a weight, so there's clearly a weight downwards all the time due to gravity. Weight is always downwards. Well, it's always in the direction of gravity, whatever that is, and that's on Earth always down. And then it's up against a surface, and because it's not accelerating up or down, it must be opposed by a normal force. And if these are the only two forces, these will be in balance, and everything is pretty clear what's going on. Now, if instead of a horizontal surface, if you have a vertical surface, and there's the piano, well, this is the cartoon version of the piano, where it's falling outside of a building towards the ground. Someone's usually on the ground, where it smashes them or something. And yeah, it still has a weight. Now there's no normal force holding it up. And it just is in free fall, basically. So the difference is, the dramatic difference here is N is not existent vertically, and N is doing nothing to oppose the weight. Here the weight is constant, but there's an N and there's no acceleration whatsoever. Here, acceleration is equal to G downwards. Here, acceleration is equal to 0. When we think about a slope, it's going to be somewhere between these two. The flatter the slope, the more like it's going to be this. And the steeper the slope, the more like it's going to be that. So the first thing we're going to notice is we're going to expect the acceleration to be greater than 0 and less than g. If there's no other forces acting on it. If it's just left to its own devices, it's certainly not going to accelerate down the hill as fast as it would otherwise fall, and it's going to be faster than 0 where it's flat. The weight is always there, and the lesson that we cannot forget is that N is always pushes perpendicular to the surface. So given these, this is now the complication, but this is the standard form. This is our starting position for all problems dealing with objects that are on sloped surfaces. We just need to remember that a sloped surface is neither completely flat nor completely vertical, and the object is going to have some kind of intermediate behavior. Weight is always down, n is always perpendicular to the surface. Here n is 0, but it's still, if there was an n, it would be perpendicular to the surface. And we're going to have to deal with this angled situation, and we're going to have to adapt some of our approaches with forces, which I'll do with this problem as the first example.